Hey guys, Dr. Brown here with Kubo Math. We're here in Tarlac City, Philippines. Sorry I've been offline for a while, but we've been coaching some civil engineering students from Tarlac State University here. They've been coming to my home and we've been in the Kubo, thus the name Kubo Math. But the next series of videos will be some of the challenges that they experienced, and today Trig Sub is the subject. So we have an integral here, 1 over x squared, the square root of 9 minus x squared, integrated on dx. Okay, you can see in general when you do say a u sub, you're looking at what the parentheses is typically. In this case I've got a radical with 9 minus x squared. If someone said, hey, let's do a u sub, well, if u equals 9 minus x squared, du equals minus 2x dx. The derivative of a constant is 0. In this case 2, bring down the 2. I've got a negative in front, negative 2. Well, it's minus x to the second. We're going to bring that 2 down. So we'll have minus 2x to the 2 minus 1, which is minus 2x, and then chain rule, dx, derivative of x. So I end up with minus 2x dx. Well, if we isolate dx, we divide both sides by negative 2. So if I divide that by minus 2x, divide by minus 2x, that cancels out here. So du over minus 2x equals dx. Wow, if I plug that in, integral 1 over x squared, then I have u to the 1/2, because u is 9 minus x squared, and it's under the radical sign. But I have now du over minus 2x. It's getting ugly here. You can see nothing cancels. I'm in the u world and also have x values. So u sub does not work. So let's move on to trig sub. You need to get to the point where you understand certain identities. For example, 1 equals sine squared x plus cosine squared x. Or you could look, once you understand that, now I can say 1 minus sine squared x equals cosine squared x. Okay, that's one form you really need to understand. There may be times where you have the number 1, and I want to replace that 1 with sine squared x plus cosine squared x. That's not the case here. All right, but what if I have tangent squared x plus 1? That equals secant squared x. Now, in this case, well, I can turn that around. 1 plus tangent squared x equals secant squared x. I could have that situation. Now, obviously, you can take the derivatives of those things. So, in our case here, we have a constant minus some x squared. Oh, a constant minus something squared. Wow. Okay. If I were to allow, let's pick a, let a equals 3. Well, obviously a squared equals 9. Okay. And then if I let x equal a sine theta, dx equals a cosine theta d theta. You recall the chain rule. I have a function. In this case I had sine theta. Well, that's the outside function. So I take the derivative of the outside function and then the derivative of the inside function. That's the chain rule. So the derivative of sine theta is cosine theta. The derivative of theta is d theta. Okay, so now then we have A equals 3, x equals a sine theta d theta, or sorry, a sine theta dx equals a cosine theta d theta. All right. So now, let's look at our terms. We have 1 divided by x squared. I know what you're thinking. Oh. Now we have the square root of a squared minus x squared. And x was a sine theta. And that's squared. But now we have dx we need to replace, and that is a cosine theta d theta. Now you may be thinking, uh-oh, we have a value of x that's still here, and I'm in the theta world. Well, if this is x, hey, x squared would be a squared sine squared theta. Just square that. So let me just put that in here. So I have the integral, that's a squared sine squared theta. That's x squared. So now all thetas, no x's. So we're successful so far. Let's see if we can keep going. All right. Let's factor this guy here. Okay, if I square this term just for the sake of keeping some space, if I square a sine theta, I get a squared sine squared. Okay, I get that. Now, if I factor, let's move down. So now we have a cosine theta, and we're integrating with respect to theta. All right, a over a squared gives me 1 over a. I'll get that out of the way. Sine squared theta. Now, under this radical sign, I'm going to factor out the a squared out of both terms. That's 1 minus sine squared theta. Oh, remember what we said earlier? 1 minus sine square equals cosine square. So we can replace this with cosine square. Now you remember the rule of square roots. If I have a times b to the square root of that, that can be noted as square root of a times square root of b. Well, I can use that concept here. Square root of a squared is a, so it's 1 over a. So I'm going to move that one here. So that gets rid of this guy. So now we have 1 over a squared, the integral of course, that a wiped out over there. Oh, no, it didn't. That a and one of those goes out, and now this a comes out, makes it a squared. All right. Cosine theta. Sorry, I have a big crack in my board here. I guess it overheated. All right, square root of cosine square is cosine theta. Oh, this is looking good. D theta. Those cancel. So now I have 1 over a squared, the integral of 1 over sine squared theta d theta. Well, 1 over sine is what? Cosecant. So 1 over sine squared is cosecant squared. So I have 1 over a squared, the integral of cosecant squared x. Sorry. Theta d theta. Cosecant squared x, so cosecant squared theta d theta. We'll get to x in a minute. I guess I'm too excited. All right, what's the integral of cosecant squared? Minus cotangent. Okay, so now I have 1 over a squared, and I'll put my negative here, cotangent theta. You may be thinking, but we're not finished yet, okay? All right, what was A? A was 3. A squared is 9, so I have minus 1 over 9, this cotangent. What are we going to do about that? Let's see, let's put our triangle here, put theta in that corner. We said earlier, x equals a sine theta. If I divide both sides by a, x over a equals sine theta. Well, what is sine? It's the opposite over hypotenuse. So this is x over a. Now, what does that mean this side is, just to finish it out? Well, that's a squared, the hypotenuse squared, minus one of the sides squared. Oh, hey, we had that guy up here, a squared minus x squared. Okay, now then, we have cotangent. Tangent is the opposite over adjacent. Cotangent is the adjacent over the opposite. So we have a squared minus x squared over x plus c. So this would be an example of how you could use trig sub, use some of the trig identities. You know, in this case, minus sine squared equals cosine squared. And then what we saw was something that looked like 1 minus sine squared. So let the constant take the square root of that number, and then let that call it a, in our case, was 3. So now we had 3 times, which was a sine theta. So that allowed us to work through that and end up with the correct answer. So I could, 1 over 9a squared is 9. 9 minus x squared, square root of 9 minus x squared over x times 1 over 9 plus c. All right, guys, why are we doing this? Together we're trying to build a better tomorrow and do that through math. So the next series of videos, like I said earlier, will be some of the challenges that the civil engineering students had when they were here at the Kubo. So we'll go through, as you see in the corner, some partial fractions. They struggled with that. U sub, trig sub, power reduction. That was something new for the students. So we'll go through those as we go along. Okay, that's all for now, and we'll see you next time. Thanks.